Hi everybody, Mr. Rubo here. Today we are still talking 2.7, doing some more composition of functions. So we are looking at this table and this piecewise graph and then this piecewise function. So um, yeah, we're basically going to be doing composite functions with different representations. So and then actually even this one down here, which tells us that k of x is a quadratic function with a horizontal translation of 2 followed by a vertical translation of -3. So before I even get going with the first example, I'm actually going to write the equation of this guy. So it's going to be k of x equals x minus 2, because we got that horizontal translation of 2. Let me fix that though. It's a quadratic, so I need to put a squared, and then a vertical translation of minus 3. So there is k of x's equation. All right, so now I've just got a bunch of composite functions here that they want us to do. And yeah, we're going to go ahead and evaluate if possible. It is 100% possible that we don't get an answer. So we're going to go ahead and start looking. So you always start from the inside and work our way outside. So we're going to do g of 3. Well, g is this table. G of 3, there is no 3 for the x, which means right away, not defined. Ooh, defined. I don't know what's happening right now with my stylus. There we go. G of 3 is not defined. So this guy is not defined at all. So no solution, right? So yeah, we're done with that one. All right, then we move on to the next one. The next one is this the h of f of 8. Again, as I said in my last video, I prefer this notation, so I'll rewrite it just so we can kind of clearly see these two things are the same thing. So I'm going to start with f of 8. Well, f is the graph. F of 8 means I go to the x value of 8, find the y value. So what this is 8, -1. So that means f of 8 is -1. But so that's me evaluating f of 8. From a graph, you just pull the y value. But then I have to do h of -1, which means I'm looking at the piecewise defined function. And at -1, well, -1 is less than 1, so I have to substitute it in to that top equation and simplify. So inside the absolute value, I would have -7 minus 3, which would be -10, but we're absolute valuing it, which means my answer there is 10. Okay, cool. And that's it. That's the answer for that one. So we'll keep doing a few of these examples just so you can kind of see more. And again, I prefer this notation, so I will pretty much always rewrite it. But again, both are mathematically correct. So here, k of 0. Well, k was this one that we wrote the equation of, so that means we're going to go ahead and substitute 0 in to figure out k of 0. So I'll kind of do is like a little scratch work on the side. K of 0 would be 0 minus 0. My stylus just now went right there. There we go. 0 minus 2 squared minus 3. This would be minus 2, but then it's squared, so it's 4. 4 minus 3 is 1. So k of 0 is 1. So I will replace it with a 1. And then I'm going to do g of 1. G is the table. And unfortunately, g of 1 not defined. So there is no answer. Okay. All right. And now we get some fun ones. So the first, this one, f of 2, or sorry, f of 2 means, again, start from the inside, but I'm just using function f, which is the graph. F of 2, all right, I have a whole or a solid point. You always choose the solid point. So 2, 1 is that point. So that means I'm going to replace the f of 2 with a 1, and now I have to solve f of 1, which means I go 1, and I see, oh, this coordinate point would be 1, 4. Y value is 4. So that means this answer is 4. Okay. All right. Then this one, again, I don't like the notation, so I will rewrite it. And I start with h. So h is the piecewise defined function. I'm finding where it's 1. Well, we have 1 in all of them, but the top and the bottom one do not include 1. Only the middle one does, and it tells us that if it's 1, it's at -4. So h of 1 is -4. And then I have to do g of -4. Well, g we haven't been lucky with, but this time g actually does have an x value that corresponds, which means my answer here is pi. Okay. And then we get this last one, which is last one is a fun one because it's a bunch of them all in a row. And the key with this is start from the inside and work our way out. So k of 3. All right, so I'm going to start by doing k of 3. And again, I'm going to do this kind of on the side. So 3 minus 2 squared minus 3. That's 1. 1 squared is 1. 1 minus 3 is -2. Okay, so that means I'm going to replace k of 3 with -2. I'm sorry, whoops. K of 3 with -2. And now I work on the next function. So h of -2. Well, h of -2 tells me, okay, I'm looking at the piecewise, -2 is less than 1, so I'm going to use that top equation again. So h of -2 equals absolute value of -7 plus 3 times -2. And when I simplify this, that's -6, that's -7, so I would get -13, but then I'm taking the absolute value, so I get 13. So again, I'm going to replace h of -2 now with 13. And now let's see if I can keep going. Well, f of 13, well, this graph unfortunately stops at 10. So after doing all of that lovely work on the first two, we get to a point where it's not defined. And we're done because there is no answer there. So yeah, that's how that's how composite functions work with different representations. You just work with each representation as you need to, and sometimes they're not defined, which means you stop and you don't have an answer. All right, well, thanks for watching and have a good day.